You need to watch this if you've ever dreamed of striking it rich. Not all gold rushes were created equal. I'm sure you've heard the stories, massive gold nuggets found in the Australian outback. If you've got gold concentrates from panning or sluicing, you're sitting on potential treasure. If you think gold bars are just movie props, think again. Turning molten gold into real money? Here's how. When gold enters a river, it doesn't scatter evenly. It follows the laws of gravity and flow. The heaviest pieces drop out first, collecting in riffle zones, inside bends, and behind large boulders. False bedrock, clay layers, or hard-packed gravels can trap nuggets just above the real bedrock. Look for sudden drops in velocity, plunge pools, waterfalls, or sharp bends where water slows. These are natural gold catchers. Prospectors who read rivers correctly aren't guessing. They're following physics, finding where nature concentrates the heavy metal. What I wish I knew before my first gold pan: bedrock isn't always what it looks like. I learned the hard way that there's more than one type of bottom in a creek. In many gold-bearing creeks, you'll hit a hard layer clay, silt, cemented gravel, and think you've reached bedrock. But that could be false bedrock. A tough layer gold can't punch through. The richest gold often piles up right above this barrier, not on the real bedrock below. Always sample where the hard pan meets the gravel. That hidden layer could be the pay streak you've been searching for. Don't leave gold trapped on a false floor. Dig smart and find the real treasure. Black sands are more than a nuisance. They're a clue. These heavy minerals, mostly magnetite and ilmenite, settle in the same spots as gold because they share high density. When you see black streaks on a river bar or concentrated in your pan, it means the water was strong enough to wash away lighter material, but heavy minerals stayed behind. Gold often hides in the same layers. Prospectors treat black sands as a map. They don't guarantee gold, but they mark the right conditions where gold is most likely to be found. Not all placer gold is in modern rivers. Bench placers are ancient river channels high above today's valleys. Over time, rivers cut deeper into bedrock, leaving old channels stranded on hillsides. These benches can hold rich gravels, locked away for thousands or even millions of years. Prospectors spot them by tracing gravel deposits above streams or finding rounded river cobbles far from water. Bench placers show the best gold isn't always where water flows today. It can hide in the ghost of a river long gone. Am I the only one who didn't know flash floods could create gold hotspots? Desert rivers might be dry most of the year, but there's gold waiting after the storms. When sudden floods rush out of desert canyons, they dump gravel at the base, spreading out in a giant cone called an alluvial fan. The heaviest gold settles close to the canyon's mouth, while lighter stuff drifts farther down. That's why prospectors focus on the upper fan, especially where bedrock traps gold, and where hard layers trap gold. With dry washers and metal detectors, these spots could reveal hidden riches. Next time you see a dry desert wash, remember, there could be gold right under your feet. You need to watch this if you've ever dreamed of striking it rich. Not all gold rushes were created equal. Let's compare California's golden dust to Klondike's legendary nuggets. Back in 1849, California miners panned for fine gold flour and dust swirling in rivers. It looked impressive, but most folks barely filled their pockets. Fast forward to 1896, Klondike prospectors in Canada were digging up massive nuggets, sometimes the size of your fist. One rush needed grit and patience. The other could make you rich overnight. Whether it's dust or nuggets, these gold rushes proved that what's beneath the ground can shape entire chapters of history. I'm sure you've heard the stories, massive gold nuggets found in the Australian outback. But did you know the biggest ever weighed over 2,300 ounces? In 1869, the Welcome Stranger nugget was unearthed in Victoria, still the largest gold nugget ever recorded. The outback's unique geology, ancient reefs' deep soils, has preserved gold in massive, coarse pieces. Even today, prospectors still pull out ounce-sized nuggets from Western Australia's goldfields. Australia isn't just about fine gold. A single monster find can change your life. Gold fever isn't just a thing of the past. South America's rivers still glitter with treasure. In Brazil's Amazon basin, mighty rivers like the Tapajós snake through ancient greenstone belts, eroding gold-rich rocks into sprawling alluvial plains. Here, placer gold, tiny flakes and even nuggets, washes downriver, fueling fortunes and dreams for modern-day prospectors. Over in Peru, thousands of miners dig shallow gravels in the Madre de Dios region, where placer fields stretch for kilometers and every pan could hold a prize. But it's not all riches. These gold rushes come at a cost, with deforestation and mercury pollution threatening some of the world's most vital ecosystems. South America's placer fields remind us just how powerful rivers can be, moving mountains, shaping landscapes, and sometimes delivering gold by the handful. Not a fan of history lessons? Well, what if I told you Africa's rivers helped shape the world's gold rush? Here's the scoop you didn't learn in school. In Ghana, ancient miners sifted river gravel so thoroughly the land earned the name Gold Coast. Over in Sudan, the Nile, its tributaries still yield placer gold fueling modern gold rushes. And in South Africa, shimmering alluvial gravels led prospectors to the Witwatersrand Basin, the world's greatest gold field. From ancient kingdoms to today's diggers, Africa's rivers have shaped history and gold supplies alike. The story of alluvial gold isn't just about riches, it's Africa's legacy flowing through time. Think gold rushes only happen in warm, sunny places? Think again. In Siberia and the Arctic, prospectors battle more than just dirt. They face permafrost, bone-chilling cold, and seasons so short, every hour counts. Rivers like Russia's Lena and Kolyma have yielded tons of placer gold. Locked in gravel so frozen, miners have to thaw it just to dig. In Alaska's far north, heavy machinery chases pay streaks buried deep under the ice. But the biggest challenge isn't the gold. It's the brutal isolation, logistics, and relentless weather. Still, some of the world's richest gold fields are hidden in these frozen frontiers. Because gold doesn't care about the weather, and neither do the people tough enough to chase it. If you think gold panning is just luck, think again. There's physics in every shake. Let's break it down. Gold is nearly 19 times heavier than water. Yep, that's why it sinks while other stuff floats away. When you swirl your pan, you're not just making pretty patterns, you're using stratification. Dense gold settles to the bottom, lighter sand and gravel wash over the edge. But here's the catch. Black sand sticks around too because it's dense, just not quite as heavy as gold. With a bit of patience, that bright yellow starts to stand out. So next time you see someone panning, remember, it's not just tradition. It's physics in action, revealing hidden treasures in every river swirl. I'll show you how to get the best gold recovery using riffles and water. Ready to see why the sluice box still rules? Let's dig in. A sluice box is basically a mini river you control. Water flows through a tilted trough carrying sand and gravel away. Riffles are raised bars that create turbulence. This slows heavy stuff like gold, causing it to drop out and settle. Lighter material just keeps washing away. For extra capture, add mats and carpet. This will help you catch even the finest flour gold. The trick is to balance your water flow. If it's too fast, your gold is gone. Too slow and the whole box clogs up. Did you know 19th century miners had to wash tons of gravel without power tools? Their secret weapons? The long tom the rocker box? In the gold rush days, the long tom was like a supersized sluice, stretching up to 20 feet. Teams of miners shoveled in gravel, using water to wash gold downstream. The rocker or cradle worked even where water was scarce. Miners rocked it back and forth to catch gold in riffle-lined trays. These simple tools meant more gold, less sweat, and bigger finds, laying the foundation for today's mining tech. Next time you think mining was all pickaxes, remember the long tom and the rocker? I bet you didn't know gold dredges come in all shapes and sizes. Some fit in a backpack, others shaped valleys. Let's dive into the world of dredges. Gold dredges totally changed placer mining. A small suction dredge acts like an underwater vacuum. It sucks up gravel and pebbles from the stream, then it separates the gold right there in the water. But things got wild with giant bucket-lined dredges. These floating factories could chew through thousands of cubic yards every day, especially in places like Alaska and Siberia. They didn't just find gold, they literally reshaped whole landscapes. Today, hobbyists use portable dredges to chase flakes. The massive old dredges remind us how technology supercharged gold recovery. From tiny tools to industrial monsters, dredges show just how far mining tech has come. Gold mining isn't just brute force, it's some seriously cool physics in action. Shaker tables are where gravity does the hard work. Here's how it works. You feed material onto a tilted, vibrating surface. The lighter sand slides quickly down and away. Quartz slides quickly down and away. The heavier gold climbs slowly across the riffles. Heavier black sand climbs slowly across the riffles. By tweaking water flow, tilt, and vibration, miners can capture even the finest flour gold. From backyard prospectors to giant mining outfits, shaker tables prove smart science gets the gold, not just muscle. That's physics turning dust into treasure. This is why finding gold in your pan might be just the start. The real jackpot? It's hiding upstream. Placer gold, those shiny flakes nuggets in rivers, is just evidence. They broke off from hard rock veins, usually in quartz. Prospectors follow the gold trail upstream, sampling gravel until it disappears. That cutoff points to the source, the lode deposit. History's biggest gold strikes, like the Witwatersrand in South Africa, started with a few river finds that led miners to massive veins. So, if you spot placer gold, remember, it's not just a lucky find. It might be the clue that leads you to the real treasure. I don't think people understand how much science goes into finding gold nuggets. Let's break down how detectors make prospectors strike it rich. Metal detectors send out an electromagnetic pulse into the ground. If that pulse hits a piece of conductive metal, like gold, it bounces back a signal the detector can read. There are two main types. VLF detectors are perfect for finding tiny nuggets close to the surface. Pulse induction detectors, they power through tough, mineralized soils to find bigger gold deeper down. From Australia to Africa and the American West, these machines have uncovered gold that others missed. With the right science and a bit of luck, one beep could mean your next big discovery. What I wish I knew about gold mining before hearing those wild old stories. It wasn't just pans and luck, it was chemistry with a dark side. For centuries, miners used mercury to recover fine gold. When mercury touches gold, they instantly bond, making a silvery alloy called an amalgam. Heat that mixture, mercury boils off as vapor, leaving pure gold behind. It worked so well, miners from colonial South America to California relied on it. But there was a catch. Mercury poisoned workers and rivers alike. Today, safer methods rule, but the story of amalgamation shows just how much chemistry shaped the history of gold. You need to watch this, if you've ever wondered how we actually get gold out of rocks. Spoiler, it's not with a pickaxe, it's chemistry. In the late 1800s, miners discovered they could soak crushed gold ore in a weak cyanide solution, which makes the gold dissolve into the liquid. This process is called leaching. That liquid gold can then be separated out using zinc using activated carbon. Suddenly, even low-grade ores became gold mines. But there's a catch. Cyanide is extremely toxic, and spills have caused serious environmental disasters. Even so, cyanide leaching is still the standard today, though safer alternatives are on the rise. Thiosulfate glycine. It's a powerful reminder. Chemistry can change the world, for better or worse. If you've got gold concentrates from panning or sluicing, you're sitting on potential treasure. Ready to turn black sand into real gold? Let's break down home smelting, fast and simple. First, dry your concentrates and clean them to prep for smelting. Next, mix in a flux like borax soda ash. Flux lowers the melting point and helps draw out impurities, making a glassy slag. Fire up a propane furnace or use an electric furnace and heat your mixture above 1064 degrees Celsius, the melting point of gold. As it melts, pure gold sinks to the bottom while slag floats up. Let it cool, then crack off the slag to reveal your button of door metal. This is chemistry and craftsmanship in action, transforming black sands into real solid gold right at home. Fire assay is the oldest and still the most trusted method for testing gold content. The process begins by mixing a powdered ore sample with lead oxide and fluxes, then heating it in a furnace above 1000 degrees Celsius. Lead collects the precious metals and sinks, while waste forms slag. After cooling, the lead button is separated and cupelled, oxidized to absorb the lead, leaving a bead of pure gold and silver. Accurate to parts per million, fire assay remains the global standard in labs today, proving that ancient methods still guide modern mining. Fire assay, where ancient wisdom meets modern precision. If you handle gold concentrates, you need this tip. There's a safer way than mercury. Let's talk borax. Borax isn't just for laundry, it's a game changer for small-scale gold refining. When you mix gold concentrates with borax and heat them in a simple furnace, borax drops the melting point of gold. Impurities get trapped in slag, leaving a pure gold button. No toxic mercury fumes, no complicated equipment, just simple, safer results. Miners worldwide use borax because it's low cost, environmentally friendly, and easy to handle safely. Upgrade your gold, skip the mercury. Cleaner gold refining starts with borax. From muddy metal chunks to shiny pure bars, let's break down the science of electrolytic refining. Here's how it works. We start with an impure metal slab. Think copper, for example. That slab acts as the anode in a special bath filled with a chemical solution. We add a thin sheet of pure metal as the cathode, then run electricity through the setup. The magic? Impure metal dissolves from the anode and redeposits as pure metal onto the cathode. Unwanted stuff just falls away. This process gives us ultra-pure metals. Perfect for electronics, coins, and more. Science makes the world cleaner, one atom at a time. If you think gold bars are just movie props, think again. Turning molten gold into real money? Here's how. Once gold is refined, it's time to cast. Molten gold from the furnace is poured into preheated graphite molds. As it cools, the liquid gold solidifies into bars called ingots. Each bar is weighed, stamped, and assayed to guarantee its purity, usually 99.99%. From tiny 1-ounce bars to giant bullion held by banks, this process transforms raw ore into the gold standard of finance. From mine to market, metal becomes money. Gold fever gripped the world. But the real treasure wasn't always in the ground. Every gold rush created fortunes, but not for who you'd expect. Sure, a few lucky miners hit pay dirt, but most spent more on tools and supplies than they ever got back. The real winners, merchants selling picks, shovels, even bread at sky-high prices. Boomtowns exploded overnight, then disappeared when the gold was gone. Railroads got richer, banks got richer, governments got richer, while most prospectors faced tough times. If you think gold panning is just an old-timey hobby, think again. Today's miners use big machines, not tin pans. Here's how modern placer mining really works. Forget pickaxes and tin pans. Today's gold hunters in Alaska and the Yukon run excavators, trommels, massive wash plants. They process thousands of tons of gravel every day, pumping water through sluices, riffles, mats that trap everything from fine flakes, chunky nuggets. Unlike the old days, strict rules now protect the water and land, and miners must restore the ground when they're done. The method's changed, but the dream? That's pure gold. Small-scale miners might recover just grams of gold a day. Industrial sites can pull out thousands of ounces. Let's compare how each approach works. Small-scale miners use pans. Small-scale miners use sluices. Small-scale miners use simple trommels. They work by hand to extract tiny flecks of gold. It's flexible and lower cost, but slow, and limits how much gold they can actually get. Industrial gold recovery is a different beast. Picture massive trucks, picture rock crushers, picture huge cyanide leach pads. These operations move millions of tons of ore, chasing efficiency and volume, but at a steep environmental and financial cost. In the end, both types shape the global gold supply, just at very different scales. Everybody's heard gold rush stories, but did you know their most lasting legacy is poison, not riches? Let's dive into the hidden cost of gold. Back in the gold rush days, miners poured tons of mercury into rivers to capture gold dust. Mercury stuck to gold, but much of it slipped into the water and never left. Over time, this mercury transforms into methylmercury, a potent neurotoxin. This toxin builds up in fish and wildlife, contaminating entire food webs. Even now, this toxic legacy persists in rivers from California to the Amazon. I don't think people understand how much placer mining is changing. Tech is shaking things up, big time. Old school panning meets cutting-edge AI. Drones now map riverbeds in stunning detail, spotting gold-rich streaks we used to miss. AI crunches geology, AI crunches satellite images, AI crunches old records to predict where gold still hides. Smart sensors and automation make mining cleaner and more precise. Tomorrow's gold rush? It'll be written in data, not just dirt.
Placer gold has fascinated miners, prospectors, and geologists for centuries. From early river panning to modern industrial recovery, the story of placer mining is one of persistence, ingenuity, and transformation. In this 10-minute explainer, we'll cover every stage: prospecting, world placers, recovery methods, hard rock connections, refining, and the economic legacy that still shapes gold mining today. Finding placer gold starts with reading the land. Rivers create natural traps where heavy gold settles, behind boulders, in riffle zones, or on false bedrock layers made of clay or compacted gravels. Black sands, rich in magnetite and ilmenite, act as a natural clue, often concentrating with fine gold. But rivers aren't the only places to look. Bench placers, ancient river channels perched above modern valleys, can hold forgotten pay streaks. In deserts, alluvial fans spread out gold-bearing gravels where flash floods deposit material. The prospector's job is to recognize these patterns and sample smartly, turning geology into guidance. Gold placers have shaped history across the globe. In California and the Klondike, contrasting deposits produced everything from fine dust to massive nuggets. Australia's outback still yields monster nuggets, while South America's rivers in Brazil and Peru have supported placer mining for centuries. Africa's alluvial fields in Ghana, Sudan, and South Africa remain active today, and in Siberia and the Arctic, frozen ground poses unique challenges. Every region tells a different story, but the principle remains the same. Water and gravity concentrate gold where it can be recovered. Placer recovery has evolved, but the physics hasn't changed. A pan remains the simplest tool, relying on swirling water to separate gold from lighter grains. Sluice boxes with riffles and mats trap gold more efficiently, while 19th century miners used long toms and rockers to process higher volumes. Modern operations scale this up with dredges, capable of moving thousands of yards of gravel, or shaker tables, that separate gold by vibration and gravity. These methods show the continuity between old technology and today's industrial approaches. Placer deposits are often just the first clue. Many lead back to hard rock lodes where gold formed in quartz veins. Detecting nuggets with metal detectors can guide prospectors toward richer zones. Crushing ore, from hand stamps to modern jaw mills, frees gold for further recovery. Historic miners often used mercury amalgamation to capture fine gold, but this came with major risks. Cyanide leaching eventually replaced mercury, allowing much higher recovery from low-grade ore. These steps connect surface placers with the deeper geology that created them. Once concentrates are collected, the journey isn't over. Smelting at home with fluxes like borax or soda ash produces door buttons. Fire assay, an ancient method still used today, remains the most accurate test of gold content. At the industrial scale, electrolytic refining achieves 99.99% purity by plating gold onto cathodes. Finally, molten gold is poured into molds to cast ingots, stamped and certified for trade. These steps transform raw gravels into bullion bars, the gold standard of value. Gold rushes created both winners and losers. While a few miners struck it rich, merchants, railroads, and banks profited most. Boomtowns rose and fell, leaving ghost towns behind. Today, modern placer mining in Alaska and the Yukon continues on a regulated industrial scale with excavators, trommels, and reclamation rules. But gold rush legacies remain in the environment. Mercury contamination still pollutes rivers, and cyanide spills remind us of the risks. At the same time, small-scale miners and industrial giants each play their role in global gold supply, with new technologies, AI, drones, and sensors, pointing toward a future of cleaner, smarter placer mining. From reading rivers to casting bullion, placer mining is the bridge between nature's processes and human ingenuity. Its story is one of persistence, adaptation, and discovery. The gold of tomorrow will still come from rivers and gravels, but guided by technology and shaped by the lessons of history.